Yeah, are you able to see my screen? Can somebody respond?
Yes, yes.
Okay, yeah. Okay, so this is another concept. The best practices are how to develop applications. Okay, it's called test driven development. So nowadays, uh, all projects. So there is a mandatory code coverage. Concept called code coverage. Why we are going for code coverage? For that we need to get the code coverage. We need to have a unit test for this thing. Okay, unit test you can write in different ways, but following test driven development will help you a lot to cover your most of the cases. So normally what you will do is whenever you'll get the task, right, we'll analyze it and we'll start writing the code. That is our normal approach, right? Whenever you'll get the task, you analyze the task and then you start writing the code and then you will test it, right? That is what our normal approach. Is that correct?
Yes, sir.
Yeah. So we'll get the task, we'll analyze it, and we'll write the code for that. After writing the code, we are going to test it, right? Manually testing it, or you're writing a scripts, all the stuff. So the approach is getting the task, analyzing it, writing the code, and testing it. So but in test driven development approach, first we will analyze the task, then we will write the test. Okay, after writing a test, and you will write the code. Writing a test is basically writing a test cases.
Better.
Okay, so that's what this approach is basically. So there is a three color. This thing is called
ఏంటి?
red, green.
Huh?
Baji, can you go on mute? Yeah, so the cycle is like this. The three color thing that you normally will call as a red, green, and some other this one refactor. Okay, so the thing is that the approach is basically you'll start it, write a test. Start is basically you got the task. Okay, so you analyzed it and you write a test first. So you write a test. The test should fail because we did not write the functionality for that. So initially we write a test, so the test should fail, and then you make it pass that test because the test is already failed, right? You write a code to pass that test. Okay, so after writing the code, you make it pass the test. If required, refactor it. Okay, that is basically improve the code and repeat the process. Okay, this is the one. So improve basically you need to clean it, or you need to add more stuff, all the stuff. And so this is the test driven development approach. Okay, so so guys, if you start writing this one, you really going to enjoy writing code. Okay, so it helps a lot. It avoids lot of basic bugs. Okay, which normally, so 80% of the bugs will be eliminated if you follow this approach. Okay, so this is a general concept. Okay, this red, green refactor. So that if you map to other thing, so red is basically so think, right? Think, analyzing. We got the task, analyze it, right? So that is basically thinking. After that, so you test it. After that, write the code and refactor it and repeat the same thing. Okay, so refactor is basically so writing the code only, and then think. So this is a cycle. This is a solution. Okay, so any questions here? Okay, so this is a general concept. Test driven development is a general concept. So but the tools, right, you are going to use, the tools are differ basing on our technology what you are using, right? If it is Java, there should be some other JUnit kind of thing. In Python, there's a PyTest, unit test. In Node.js, we have a just chai, all the stuff. Okay, in each technology is having their own packages to implement these unit tests. Okay, so let's see the demo how we are going to write the unit test, all the stuff. Okay, so if you write unit test is basically so there are different kinds of testing methods, right? So you have a integration test, load test, performance test, all the stuff. So whereas unit test is done by a developer. Okay, so unit testing is done by a developer, and this unit test should complete in less time. It should not take more than 5 minutes. Okay, for 5 minutes also, 5 minutes is a maximum time limit to complete all unit tests in your project. Okay, so that's a quick to test it. You can cover all the things. That's one. So here I'm using a word cover. So covering means basically you write the code actual functionality. So whether you covered unit testing for that functionality, that we call as a code coverage. Okay, so normally the standard industry standard is not 100% code coverage. Normally 75 to 80%. That is the industry standard. If you cover 80% code coverage, that is okay. But some companies configure that value is a 90%. Some may go to 70%. Okay, so at least 75 to 80% code coverage should be there to benchmark our quality code. Okay, so any questions here? Okay, let's go to demo then. So I'll show you a demo. I just clear it. Let me clear this one. For easy understand purpose, I have taken very simple code. Let's take add and subtract. Okay, there are two methods. So addition of two numbers and subtracting two numbers. Okay, so let's take this one. Let's see how to unit test this one. Okay, so normally so for writing a unit test as per our TTD approach, whenever you get a task, instead of writing a code, you need to analyze and write the test cases, right? Okay, so let's take a scenario. So our task, assume the task is adding two numbers and subtracting two numbers. There are two scenarios. Okay, so let's assume implement a application which can perform add and subtract two numbers. Okay, so assume this is a task for us. So here basically there are two functionalities. One is adding two numbers, another one is subtracting two numbers. Subtracting two numbers. So I'm not sure why my system got slow after sharing this one. Let's say adding two numbers. So what are the possible test cases for this? You guys want to tell? What are the possible test cases? Hmm? So basically two numbers, right? Two numbers could be integer. Am I correct? Can we say this as one scenario?
Yes, it's on that.
So so now can you tell me other possible scenarios?
Float, you can send.
Right? Float. Have you ever think of these
You
things?
can pass string also.
Yeah, string. Have you ever think of these scenarios before test cases, the test driven development? Yeah, my system is very slow.
Negative.
Sorry? String.
Yeah.
Any other cases?
Negative numbers.
Negative numbers, right? So let's take negative numbers. See. Negative numbers. Okay, negative. And any other cases?
One number, one string we can test.
One string and one number.
Right, one number, one string. See, so a lot of test cases are coming, right? When you are started writing test cases fast, you are going to cover all the edge cases. That is the advantage of writing following test driven development approach, right? So let's take this is int and string, right? So all these combinations. So now let's write a as per test driven approach. What is the first step? We write the test cases, and first thing is test should fail. Am I correct? Okay, so first basically you need to write add numbers let's take this is return 0, so this will fail, right? So now add numbers, anyway this will fail. So here now you will passing two numbers, num1, num2. So next, so what is the first step in the test cases? Basically first step is line number 7 is basically first whether these two numbers are integer or not, right? We need to check that. Am I correct?
Yeah.
Guys, you are following, right?
Yes.
Yeah. So because why you need to verify your data types. Data type is the key thing here. Most of the time your application is going to fail because of mismatching data types. That's why you should always validate expected data types. Here the question is implement application which can perform add or subtracting two numbers. Okay, basically we need to check for numbers. If it is not a number, you should reject saying that it's not a expected output, input. Am I correct? So everything you need to map with the problem statement. Here this is adding two numbers. So numbers, we are expecting a number. If we are receiving a string, you should not process it. You should throw exception or something else. Am I correct? You guys are following it?
Yep.
Okay. So now, so here you can check that if num1 is int or not. I'm just writing text, not following Python syntax. Is not int, return 0, right? So here this case we need to return false, and the same thing I need to check for n2, else return a plus b, sorry, n1 plus n2. Okay.
So every time before writing the data type only before we need to verify in this case.
Sorry.
Data type only we are checking before.
Now here, because our task is adding two numbers. Okay, so see here, while coding or while programming or developing a software application, you not only check for the data type, expected data type, you should also handle all the data types. Okay, let's say the task is let's say you have written like this. What will happen if the input number one value is string? What will happen? Do you know? We don't know, right?
Yes.
We know this will work. This function add number function will work only for integers. That is for sure. Or maybe it works for number, right? But we are not sure whether it may throw valid error for string or not. We don't know. Let's say what will happen if you pass a array. What will happen if you pass a JSON string? We don't know, right? Are you getting my point?
Okay.
Yeah. So
Before itself we are validating that values.
right. So those values were it's kind of possible scenarios to fail your application.
Okay.
You need to handle, so while writing a test cases, right, you are going to write note down all possible failure cases.
Okay.
Okay, it's not about a success case. See, testing is all about failure cases. You need to think like where it is going to fail, where is it going, how it is going to fail, where it is going to fail. Those cases we need to handle. Okay, that will come when you try to write all the possible cases before starting your development. Okay, so this simple thing, let's take this best example. I will write this one. This adding two numbers. I am writing a program for this. Print add number 2, 3. Okay, so what is the expected output for this one, guys? Can you respond?
Five.
5, right? Maybe I'll write more simple here. Result is equal to add. Yeah, it looks simple, but just so bear with me. So this will help you a lot. 2, 3. Okay, print result. Let me run this one. Q3 source dot py. We got 5. Okay, so this is working fine. This is what we expected. Normally whenever you get a task, right, you will straight away write like that. Most of the people, whenever we will ask to write a program for adding two numbers, most of the people will do this one. Majority, 90% of developers will do like this. Am I correct? But the thing is, yeah, it is working fine for numbers. Let's take, so as a senior developer or senior experienced people, you should not do only this one. You should think in such a way that where is the possibility of failure for this function. Let's take, this is one thing. Is it possible? Can I do like this? This is in Python, it is a valid scenario, right? In Python, it is valid. right? Let's see what will happen. Did anybody can you guys expect what is the output for this one?
I think so.
Hmm?
6.
So now let me rephrase this one. Line number 27, answer is, what is the answer?
5.
5. So everybody confidently says that at line number 27 result value is 5. Am I correct? But whereas line number 28, some people may not answer, say that we don't know. Some people will give some other answer. So all people may not give a same answer. Am I correct?
Okay.
Yeah.
So because we don't know what is going to happen, let's try it. What will happen? See, we got error. So now we got error. So this is not allowed, right? This is error means your application crashed, right? We did not handle the error properly. So this is where comes all these validations. So this method expects integer data type, but you are getting a list which is not allowed, and we did not handle that. Okay, so that's why we need to write the code to validate your input. So your application should work only for expected data, and for all other all other data you should throw proper error. You should not have a unhandled exception. You should always handle it and throw a proper error. So here let's say if I think is instance int comma n1. Okay, so you're getting line number 16 and 17. I am handling it for n1. If n1 is not an integer, I am throwing a valid scenario saying I am returning false. So I handled it. Got it? Guys, you are following?
Yeah.
Yeah, let me run this one. Is instance argument 2 must be type of tuple or types. What is syntax for this? Okay, or maybe I swapped it. So is instance is a Python method which will check for a data type of a given variable. Okay, so here I am expecting n1 value should be always integer. If it is not integer, I am returning false instead of unhandled error. You see, so this is error. So your server may go down if you're not handling properly. That's why if it is not a integer, I am throwing an error. That is expected. So like that, so here also int. So now anything. So here, so this code will handle all the data types. This method will work for any input data type. Are you getting this statement? So this code is valid, right? Do you guys having any questions here?
No.
Okay, so this is how we need to write the code. So basically here, so why we have added this thing, because initially we wrote that's the test cases for this function. What are the possible input values? Okay, so what are the possible possible valid scenarios, invalid scenarios, all those test cases we are writing initially, and the same code we are implementing in the code. Okay, so now let's test this whether test cases, because still we did not wrote the test cases, right? We just added the method. Let's see how to write the test cases. Okay, so here those test cases will have a separate method. So that method is having actual values and expected values. It's always actual values should match expected values. That is normally we'll call as a test case. Okay, you're getting my point? So whenever, so it matches expected value and actual value, that will treat as a test is passed. Okay, so here what are the test cases we have written? So line number 7, it's having a 2 integer values. Next one is 2 float values. Next is 2 string values. Next is 2 negative numbers. Next is integer string. So like this we have a test cases, right? So we are going to write those test cases. Let's see. After writing test cases, I will explain what is the test framework, all the stuff. Okay, so here there is a separate file for testing, that's why I created one. So in that I'm importing add numbers. So we are going to test add number, right? So let's take test add number method. So first I'll write this one, later I'll explain. So add number, let's take, what is the first scenario? First one is integer, right? So integer, you can take, let's say 10 is integer, 20 is integer. What is the expected value for this thing? 10 and 20. If you pass 10 and 20, what is the expected value?
30.
Guys, can you respond? 30, right? So if you pass 10 and 20 is a expected value. And let's say what is the actual value. So if you call this method, it is going to get some actual value, right? We are passing, we are calling this method, so it is giving. So here if expected value is equal to actual value, that thing we call as a test passed. Okay, else test failed. Okay, so this is how we are going to write the test cases. So we have a expected value, we are getting the actual value, both should pass, right? So this is how we are going to write a test case. Do you guys having any question here?
No.
Okay, so now this is a one test case for all the possible scenarios. So there's a first case int. Next let's take another test case for so adding floats, right? Now let's take floats. Let's take this one. See, float values. Let's take 10.0, 20.1. What is the expected value for this? Guys, by seeing code, can you tell me, if we pass two float values, what is the expected result?
False.
False,
Yes.
right? Is everyone
Yeah.
agree on that?
Yes.
Why false? Next question is, why it is returning false?
Not an integer.
Hmm?
It's not an integer.
Okay, so where we decide that one? In which line we are deciding that one?
16.
Line number 16, right? At line number 16 we are checking n1 with the integer data type. The value is, input value is float, and comparing with int, that is false. So line number 17 it is going to return. Yeah, so that we are clear, right? So that's where we are getting a false. So what is the expected value here? False, right? Let's see what is the actual value, then the same thing. Okay, can we run this one? Let's see. Oh, you did not run this one, right? P3 test. What is the file name? Source tester, sorry. Okay, do you know why it is not calling? Because we are not calling these methods. Okay, let's run these methods. It's taking some time. This number one underscore number one. Okay, test is passed, test is passed. Okay, do you guys having any question here? Now if you see, the actual code is having only less number of lines, whereas test cases will increase, lot of test cases will come. You're getting my point? See here, even though this looks so simple, the functionality, but here we have a lot of test cases. Int, float, string, negative, integer string, and the combination also will come, right? Like this you need to write the test cases. So here we are writing these things, right? So method, all this skin, and wherever whenever you need to test that, you need to call these methods. So to avoid all these things, so there is a framework, it is automatically run your test cases. You need to follow that format. Okay, there comes your unit testing libraries. In Java it's JUnit, in Python we have PyTest, unit test, and lot of things. Okay, so instead of writing all this kind of one, so you can write like this. So right here, method name, expected value is 235. First add number one. Okay, so now if I run, so I'm using a Python library PyTest to run these test cases. You can do, so PyTest, you just do PyTest. Okay, now these three tests got passed. Are you getting my point? You have any questions here?
These are the libraries, right? Unit test cases.
No, unit testing is a framework. So unit test is a common word. Okay, so like test driven
Framework.
development is a concept. Using test driven development concept or so methodology, you can write a unit test cases. Okay, so for writing test cases, so you have a libraries. Each technology will have its own libraries. Python, we have a PyTest and unit test. These two are popular libraries, Python and unit test. Okay, so whereas in Java we have a JUnit, and in Node.js we have something different package name. Okay, so these frameworks will help you to run your Python unit test. So lot of boiler code it will write for you. It's like giving, say, three tests passed, all these utilities it will give. You just write the test cases and it will run by using that package. Okay, you're clear right now? Any questions here?
So without using the framework itself, we need to write the code. Our approach
Right,
is
yeah, so it's like writing same in Python. It's like writing Python code only. Okay, in Java it's writing Java code only, but while running your test cases, your actual library will help.
So
Okay,
in this, when you are using the libraries like your
PyTest.
PyTest and all, without writing the code, it will fail, right? I mean, proper code.
Yeah, it will fail. I'll show you here. Let's make it fail this one. 2 plus 3, right? So somehow, so you modified this one like this. Let's see what will happen. So expected is actually 2 plus 2 should be 4, right?
Yes.
I am comparing with 5. So this thing you should fail. Let's see. Right? So here the test add number is a test case failed. So we are expecting 2 comma 2 is equal to 5. Asset is 4, actual is 5. We are expecting 5, we got 4. So this test case is failed. Like this it will give. The framework will show you everything clearly. Okay? Any questions?
Yeah. That PyTest is a command, right?
PyTest is a library. So to run this one, we are using a PyTest. Okay, PyTest is a command. Yeah, you can say that. Yeah, PyTest is a command to run this unit test cases.
Okay. But how did it identify that particular file and run this?
That I'll tell, because I want to understand. So that is actually running the stuff, following some standard approach. I'll tell that. So first we understand these things, then I'll go how to configure all the stuff. Okay, that's why I did not mention it. Okay. So our main thing is to understand how to write your test cases. Okay, you are clear now. So here I want to highlight one more thing. If you see method names, here I am using test underscore add number something, some randomly I am giving. Okay, so normally you should follow method names also. I'll tell. So method names, normally if you are testing a scenario, what are the testing scenarios here? First scenario, we are going to test for 2 integer numbers, right? So here the test method should be, test case method should be test Okay, starting with the test underscore, okay, add two integers, two ints, okay, return success. Method should be like this. You're getting my point? If you see test case, by seeing the method name, you can easily identify what is the test case, right? This method is for adding a two numbers, both are integers, and it is going to return a success. Okay, you're following it? This is one test case. Let's take another test case, failure test case. Another one.
This is how we need to write the approach.
This is a standard approach, because by seeing that, so we can by seeing test case name, you can see the what is the scenario, right? So here add here we'll say one int and one float, one int like this, one int, one float, return false, right? One int, one float, return false, right? One int, one float. See, this is false. Okay, fine. You're getting this pattern?
Yes.
Okay.
That's
Yeah.
All possible methods we need to write in a one specific
Way,
methods.
yeah. So that because you are going to run these things, every time you don't need to go to the code and see. By seeing a method name, you can easily understand that.
Okay.
Okay, and one of the biggest advantage of writing unit tests is you can eliminate lot of regressions. What is a regression?
Okay.
You'll have regression.
So
Huh?
all possible scenarios.
No. So regression issues are will use
Yes.
that regression issue. Let's say your functionality is working fine, and you got one defect, and you fix that defect. By fixing
one
that
more
defect, because of that defect, it may introduce some more defects,
Yes.
right? Those kind of scenarios you can eliminate if you have a unit test. Okay, I'll tell you one example. When I'm working in a Kony, okay, I was under the Gautam Goenka's team. I was writing the code, and so we got one one issue in iOS. I fixed that iOS issue, but it is not working in Android. Okay, so I fixed for iOS, it affected Android somehow. Then at that time, Gautam Goenka started implementing this test-driven development approach. He explained me separately and later the whole team. That effect is called butterfly effect. You do something here, and the effect will be somewhere else. It's not related to your current place. Okay, that's called butterfly effect. You will avoid these kind of scenarios if you write a unit test. That's why people are forcing to write unit tests. If you have a unit test, you can confidently modify the code, because if you modify something, existing unit test will fail if it is not working. Okay, so in that way you're completely avoiding regression issues. That's why unit tests are very, very important. Okay, any questions, any doubts here? Fine. So now let's take so existing thing. So this basic for addition I have given you. Okay, so this is how to write unit tests and writing unit tests. So here the one is a methods method name we need to follow like this. Okay, so next how these tests are identified, how to write the what are the file names for testing and source code and test case test files. There is a pattern. So all test file should start with the test or end with test. Okay, all test case involved files should start with test or end with test. Okay, so here see my source actual file name is source.py, that is my actual code, and so my test case file is source underscore test. Either source underscore test is fine or test underscore source is also fine, anything is fine. Why? Because your testing frameworks looks for those files. Okay, they will look for test star test files. Okay, either starting with test or ending with test. That's why you should always use the file pattern. So here that's why my file name is here is see actual file name is source.py and my test case file name is source underscore test.py. Okay, so now if you write like this, your testing framework look for those files and they will execute only those files. Okay, so that's way. So if you ask when I'm running a PyTest is my Python unit testing library is a PyTest, and I'm running PyTest command and it will look for the test files and it will execute. Okay, I think Gauri, you got the answer for your question. Here whenever I am running PyTest, so it is looking for, see, it is running only source test.py and it is giving the results.
Okay.
Okay, so like this here in Python it's a PyTest, maybe in Java some other utility, Node.js some other utility, but overall high level is same structure. So following method names are same, expected value, actual value are same, everything is same. Okay, so now let's take you can say that I already written a unit testing. Okay, you can say that, but people will not believe words, right? You should show the results. Okay, whether you have written the unit test for your source code or not. To confirm that, we have a concept called code coverage. Code coverage will give you the how much unit test you did for your actual source code. Okay, that we'll see here. So I'm going to delete this for now, just anyway you got this point. So I'm writing, so I have a two methods. How to check whether you have written a unit test for this code? We don't know, right? So you can say that I already written the unit test for this code, but how to prove that? So to prove that, we have a code coverage thing. So for code coverage also we have a packages, like each software is each technology is having its own dependencies. Like PyTest we have unit testing PyTest, right? Like that code coverage you have a coverage, just a coverage package is for this one. Okay, what code coverage will do, right? Coverage packages will do, it will show you the graphical representation of what covered and what not covered. Okay, and it will give you the complete percentage in a web page. You can clearly see that. Let me run this one. Actually, I have written some script for that. I'll show that. So this coverage, I'm running a code coverage thing. Okay, so it is see, basically source.py. If you go to source.py, it is covering 50%. Source.test.py, it's covering 6%. That is fine. Let's take source.py. Source.py is our actual code, correct? Source.py is having add two numbers and subtracting two numbers. It's having 50% code, and the code coverage it's stored here, HTML index.html file. Okay, so let me open this. Okay, here if you see the code coverage, source.test.py is having that one. Test, normally test you no need to cover that, you just ignore it. So actually our concern should be actual source code. Source.py is our source code. How much it is covered? Let's see here. Okay, it is missing line number 7, line number 11. So it is not covering a unit testing. You are getting my point? So we did not run a unit test for these two methods, because in source this one, so you see here all this code I commented, that's why it is not giving that code. Let me delete this one. Okay, so now we have add, subtract. These are two methods I am importing. So now added two things to add method and subtract method. I have added two test cases. Let me run this one. I'm running a code coverage for this again. So I will explain how to run the code coverage. Just first I want to show you the how code coverage works. Okay, so now see the source.py covered 100%. Let's see how see here return a plus b is not covered, return a minus b is not covered. If I refresh now, see all is passed, 100% is verified. This is how we'll show that okay, these are the lines I covered by unit test. These are the lines we covered by unit test. Okay, yeah, you're having any questions here? Let's see how to run code coverage. So because I have written a small script to generate that, so if you don't want coverage report, you just run that by running this command. Coverage is a Python package and I am running that for PyTest. Okay, so this will give it will not generate a report, so it just passes that. Okay, so if you want to get the coverage report, so you just take this one. All these things you should combine together and you need to run. That's why I keep that in a file and I'm running it. Okay, any questions here?
Can we write test methods? I mean, test cases for any kind of methods?
Yeah, you can do for any kind of methods. The thing is that let's see. So any kind of methods you are using that word. So that means what are the kind of methods you have? That is a question,
I
right?
mean, so this is simple kind of A plus B, right?
Right.
There are
Okay.
some kind of complex methods will be there,
Complex
like
methods
some
like.
uh,
Yeah. Okay.
like web service calling and
Okay.
those
Yeah.
kind of.
Let's take that one by one. So here. So you are saying it's simple because it's having only one statement. There are no if, for loops, all the stuff, right?
Yes.
Now let's take a scenario. That's why let's take if a is greater than b. Let's take this scenario. Okay. This is also written a plus b. Now let's run this yeah, unit test and see the coverage. Okay, if you see earlier unit coverage was 100%, right?
Mm.
Here now it is 83%. It got reduced because you added some code. Okay.
Okay.
And see, so that is how the complexity increases. In your case the complexity is so if you add more code to the function it becomes complex, right?
Yes.
So here I added some more code and that's where it got reduced to 83%, 100 to 83%. So what is that one? Let's see what is that 83 100% to 83 it got reduced, 17% decrease. What is that? Let's see in the code coverage 5. Okay, so you can see clearly, right, which one is we are not covered,
Yes.
right? So here we are missing that condition. If a is greater than b it is returning a plus b, but so forget about the logic, but somehow we missed covering that condition, line number 7, if a is greater than b. Okay, so we need to add a new test case for that line. Okay, so that line in source test go on, here is add. So see it's always a greater than b, then it's, oh, a less than b. So that's why see these two cases. Now I can add here a greater than b, right? Let's make this one is 5 and this result is 8. You are getting my point how I am going to fix it?
Yeah.
So
Yes.
this
Yes.
is the thing, and you can run um, coverage. Now we have 100% because we added a new code, and that new code we also added a unit test now.
Okay.
Okay, so now this basically unit testing is nothing but what is the actual value, what is the expected value. That is the thing. You need to write all the cases for that. See, normally how many test cases you should write for a given function, that is a question, right? So normally most of the people will miss that. So the thing is that, so first thing is if you have a if condition you need to write true state for true and for false, so two cases will come. Okay, if you are using a if condition there should be at least two cases, one is for a true case, one is for false case, both you should write. Okay, and other thing is if you are passing a parameter you should check the input values for that parameter. What are the possible input values? You should check all the data types. So let's say if integer a that you are expecting integer, you should check for string, check for character, check for list, check for JSON object. Okay, so all these things you need to write. That is the maximum number of test cases you will get. Okay,
Okay.
and you're talking about web services, whatever it is, right? Web services connecting with the database.
Yes.
Okay, so normally these are the scenarios. So those things that we'll call as external resources. Okay, web service, like if you are trying to access anything outside your code, see, I'm saying outside your code, accessing a file is outside your code, file is not within your code, source code. Function is within our code, but accessing a file is not within our code. That file is external resource. Database is external resource. Okay, external web service or API call is an external resource. These external resources, so while you are testing, those resources may not be available when you are running your test case. For that, you need to stub it, mock it. So most of the people use so both the words synonymously. That's fine. There is a minor difference, but fine. We can use stub and mocking or same. Mocking is fine. So mocking is basically, let's say you are making a DB call. Why you are making a DB call? That's the first question. Okay. Let's say in your function. Let me try that. Get your details. Let's say this is your method. In that, get user details. User detail obviously you need to get from the database, right? Get from the
Yes.
database. So this database may not be available always. So you get the database details from the database. That is fine. So what are the expected values from the database? That is what you should understand. Okay, get user details. So you are going to read from the database whether that expected result from the database, whether it is a list, is it a list or is it just an object? So that we need to understand. If it is a just an object, so make a dummy copy of it. If it is a list, make a dummy copy of it. Any value is fine, right? Basically values change, but keys will not change, right? If user details normally name, mobile number, date of birth, these are the things. So we'll stub response like that and we'll return that value. That you need to understand. It's a concept. If you understand that concept, you can easily implement it. Whether it's an API call, database, or file, it doesn't matter.
Okay. Instead of those web services, we'll just whatever the output, we'll pass it.
Right. What is the expected output for that API service? We'll stub that and we'll return the value.
Will it give you 100% code coverage?
Yeah, that is giving, yeah, that will give 100%. So basically
So-
code coverage, let's say, see here, you have a 3 lines, whether your code is hitting that line or not, that is important. Okay, so let's say here this is get from the database, we have this one, we want to process it. Let's say process something, process step 1, let's say process step 2. So here we have a condition. Let's take this is if condition. Okay, so if we have one process 2, this is process 3. Process 3 is in else. Just for your understanding purpose, I am writing this. You are getting it right, whatever I am writing.
Yeah.
Here this is a else part. Let's take else part. Code coverage depends on each line. Here 13, line number 14 is one statement, line number 15 is one statement, line number 16 is one statement. You should cover all the lines. Anyway, if you make get user detail method, obviously 14, 15, 16 will hit, right? Those are straight lines.
Yeah.
But so line number 18 and line number 20 will not hit at a time, right? Either 18 or 20. So you need to write test cases. One is to hitting line number 18 and another test case to hit line number 20. So if you write 2 test cases, this becomes a 100% code coverage for this method. Get user details method is a 100% code coverage if you hit line number 18 and line number 20. Otherwise, is a less than 100% because we are hitting either 18 or 20. You are getting? Guys, any questions here? Okay, then I'll stop here for today. Let me know if you have any questions. Otherwise, I'll close the session for today.
This is all
So,
architecture, right?
Sorry?
So this is we used to call test-driven architecture.
Test-driven development approach.
Okay. So,
Okay. Yeah, maybe if you are confusing with test-driven development, you forget about this. But only you need to write a test cases. The
test cases.
advantages are these things. You can eliminate lot of basic defects,
Regression issues and
regression issues, and you
and
can confidently modify the code.
yeah.
Okay, you no need to hesitate because what will happen if you modify here, because you already having a test cases. If you modify it, if it is wrong, your test case will fail.
Okay.
Yeah, so like that.
Go ahead, Shiva. You are asking something.
no. See, suppose we want to check with like database connected or not. That could be one condition, right?
Or database connected or not will not come into the unit testing thing. That is an external resource.
Environmental issues.
Right. So is a part of, see, this is a unit testing framework to unit testing concept. So whereas connecting to the database is an external resource, you're connecting to the external resource. Okay, that is a part of integration testing. Okay, so the unit testing is, let's say you already connected, it assumes you already connected to the database. If you connected to the database, what is the expected value? Okay, whether you connected or not, you should know what is the expected values, right? If it is not expected value, you should handle it basically. Right? So that is what unit testing purpose. Unit testing purpose is not to connect to the external resource. If you want to try that, you should go for integration testing. Integration testing is connecting other modules, right?
Yeah.
That is a part of that one. Yeah, that's why we are stubbing, because we are assuming we are only connected to the database. If you connected to the database, what is the expected value? That value we are processing it.
Okay.
Okay, then I'm
Successful cases also, like the DB connection is done, then we can this test case will pass, right? Otherwise, don't.
No, we cannot say. See, connecting to the database will not pass test case, because let's say you are connecting to the database, get user details, you connected to the database. What will happen if the database is returning an empty value?
It will fail, obviously.
So but that condition you should handle it.
Okay.
If you are returning a database empty, say that user not found.
Okay.
That you should handle in our code. That is a corner case, right? That's a failure case. Let's say the database is returning, let's say whether user details, whether details are expired or not, those conditions should check, right? Yeah, that kind of thing. Okay, then I'll stop here.